Hello everyone, today we are going to discuss the estimate of RCC column. So let's take an example. In this problem, we are asked to prepare a detailed estimate of RCC column with foundation footing. In this particular chapter, the emphasis is given on schedule of bar. So besides the quantity calculation in preparing the abstract of cost, we need to prepare one schedule of bar also. Whenever you do estimate, go through the drawing first properly. You need to see the dimensions and the placement of reinforcement properly. I will discuss all this as we proceed on this problem. So prepare one table in this form. So in this figure, you can see the section is here. This is the section. All the details are given, and this is the plan. So whenever we are asked to construct one RCC column with foundation, what will you do first? Of course, we will excavate the ground, right? So the first item of work will be earthwork in excavation in foundation. And the number will be 1, as we are asked to prepare only one RCC column with foundation. So go to the plan. You can see this is a square footing of side 2 meter. So length and breadth will be 2 meter and 2 meter. Number will be 1, and height will be whatever like how much portion is below the ground. In this section, you can see this is the ground level. So below the ground level, this portion, like this much, is 75 centimeter, and we have one thin layer of 8 centimeter of cement concrete. So adding this to like 75 centimeter and 8 centimeter, we can have 83 centimeter, which is equal to 0.83 meter. So we can put it as depth. So we get the number, length, breadth and height. So multiplying all this 4, we can have the quantity as 3.32 meter cube. So after excavating the ground, what will you do? We will pour one thin layer of cement concrete in the base. And that layer is 8 centimeter thick. So next item will be cement concrete in base. Length and breadth will be same as the excavated ground, and the number will also be 1, and the depth will be 0.08, that is 8 centimeter. If we convert it in the meter, then we will get it 0.08. After multiplying all this 4, the quantity will get as 0.32 meter cube. After this 2, we will do the RCC work. The RCC work I have summarized in 2 separate item of work, that is RCC work in the footing and RCC work in the column. See, the third item is RCC work in footing. But in this section, you can see, if we draw a straight line from here to this point, you can clearly see this is a rectangle and this is a trapezoid. So we will do the calculation separately for the rectangular part and the trapezoidal part. So for the for sub point A, bottom square portion sorry, this is rectangle, but the plan is square. Okay, so I have mentioned here as bottom square portion. So length and breadth will be same, like 2 meter and 2 meter, but the height is, okay, here it is given from this portion to this one, the straight edges of 25 centimeter. If we convert it to meter, we will have like 0.25. Multiplying all this for the quantity we get is 1 meter cube. Okay, so for the trapezoidal section, this is the bigger edge and this is the smaller edge and this is the slanting. Okay, so for trapezoid we are going to use the formula, this one, to find the volume. Okay, volume equal to h by 6. H is the difference between this two edge. Okay, and the area is area 1, area 2 plus 4 times of area mean. What is area 1 and what is area 2? You can see this is the bigger edge and how much is length is 2 meter. Okay, by considering the bigger edge we can have one area, and by considering the smaller edge we will have one separate area. That means the two area is by considering both smaller and bigger side. Okay, I have already mentioned here 2 square and 0.35, and 0.35 is this much. Okay, and height is 0.5, this much. You can see from the section, this is the height, and the mean area will be, we have to find the mean as 0.35 plus 2 divided by 2, and if we square it up, then we can have the mean area, but we have to add 4 times of it. Okay, by doing so we will have the volume as 0.804 meter cube. Adding this 2, the total is 1.804 meter cube, which is the quantity for RCC work in footing. Okay, next coming to RCC work in column. See, in this section you can clearly see the column portion up to plinth level it's square. Okay, and above plinth level it's circular. How can you say it's circular? You can wait, I'm giving you one clue for that. Okay, see, if the break line is like that, okay, then you can say it's a square or rectangular column. Okay, but can you see that kind of break line here? No, right? Here the break portion is shown as like that. Okay, see the difference. If the break line is shown as like this, then that's a square or rectangular column, but in this case you can recognize it as circular column. Okay, this is the simple trick you need to remember. So see the diagram. From ground level to plinth level it's square, and from plinth level to beam it's circular. Okay, so like the previous one, that is RCC work in footing, RCC work in column, we are going to calculate under two hand, that is number A, square portion below plinth level and circular portion above plinth level. Square portion, how much is this this length? 35 centimeter. So for square portion below plinth level, number will be 1 and length will be 0.35 and breadth also will be 0.35. But the height is, what is the distance between ground level and plinth level? It is 60 centimeter. Okay, that means 0.60. By multiplying all this 4, we can have the quantity as 0.074 meter cube, right? Then coming to the circular portion of the plinth level, see the diameter is, it's given 30 centimeter dia, and the height, we need the height from plinth level to the beam. The height is given as 3.30 meter. Okay, so diameter is this one and height is this one. We are going to use this formula, volume equal to pi d square by 4 into height. Putting h and d, we will get the quantity as 0.233 and the total is 0.307, and this is the quantity for RCC work in column. Okay, so until now we are done with the RCC work calculation. So heading towards the steel. Okay, so next item of work will be steel reinforcing bar including bending. In this figure, always start from the bottom. Okay, after laying this cement concrete layer, what will you do? Like, we will place one screen or bar like this. Okay, so in this section you can see this is one way. Okay, we'll put in this way. We need to bend up the bars in both ends. This is in one way and this is in another way, that is in the vertically. Okay, like if one is longitudinally, one is in the transverse direction with respect to the first one. Okay, so see, in steel we are having the first subheading as 12 mm dia bar and 0.89. How can we get this? 12 mm, that means 12 square divided by 162, we will have this one. Okay, this will not be given, you need to find it in base footing. Okay, why we are considering 12 mm only? Because it's given. See, 12 mm base, 15 centimeter center to center, both ways. Okay, so first of all we need to calculate the length. Okay, the length was 2 meter minus the cover 4 centimeter from both ends, that is minus 8 centimeter, plus bend for, if this one is the visible, okay, this is the length, and 2 for hook, 2 into 9 into D. Okay, after calculation the length we get is 2.14 meter. Okay, and the number, see, we have already, see, the number is critical. Okay, we are having this area, that is 2 meter and 2 meter. This is the bar with hook. Okay, so the length will be total length minus cover from both ends, right? So we need to distribute the bar in this portion only. That's why 200 minus 8, 4 centimeter, this is 200 centimeter, 4 centimeter, 4 centimeter, that is 8 centimeter. The remaining portion we need to divide it by 15. Why? Because it's given the bar is placed at 15 centimeters center to center. Okay. Y plus 1. See, if we divide this portion in a spacing of 15, suppose this all the gap is equal to 15 centimeter. Okay, one portion, one part, two part, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so at the end of each part we are going to place one bar. Okay, see, for this part we are going to place the bar here in the right hand side, but after doing so we need to place one bar in the front also, right? That's why in the number we need to add plus 1. Clear? And as a whole we are multiplying it with 2 because we are placing those bar in both ways, that is in longitudinally and in the transverse direction also. So n will be 28. So for the quantity we have to multiply the number, length and also 0.89. Okay, see, length is in meter and this one will be kg per meter. Okay, meter cancel, so this quantity we will get it kg only, and this is 53.33 kg. Okay, so now coming to the dual bar. What is dual bar? See, in this figure this is the dual bar in the footing portion. Okay, dual bar, 6 numbers, 16 mm dia. So we are given a 16 mm dia dual bar at 1.58 kg per meter. Number is already given, we need to calculate the length. Okay, for length again go to the diagram. Okay, 0.45. What is 0.45? This overlapping portion. See, this is already mentioned here. Okay, 45, and from this part to this one. Okay, from ground level to this given as 0.75, but we need to minus this portion like 0.08. What is this? This gap is 0.8. Okay, plus 0.15, that means 15 centimeter. Why 15 centimeter? Because the bend is given as 15 centimeter. Okay, so the length will be 45 centimeter plus 75 minus 8 centimeter and plus bend 15 centimeter. Okay, after calculation we will get the length is 1.27, and to get the quantity we need to multiply number, length and this quantity, and you have to find it by your own. Okay, and the formula is d square by 162, and here d is the diameter of bar. Okay, next coming to the vertical bar. See, vertical bar, 6 numbers, 16 mm dia. Okay, 16 mm dia bar and 158 kg per meter in column number 6. And what will be the length? For length we are giving the vertical bar is from this point, that means from ground level we are placing from ground level to the beam. Okay, from ground level to plinth level it's 60 centimeter, and from plinth level to beam it's 3.3 meter. See, 3.3 meter plus 0.6 plus 10 plus 10. What is this? One is for bend, one is for this one. See, you can see the bend, it's given as 10 centimeter bend, and this one. Okay, the column is up to this point and the beam starts from here. Okay, and we have to place the bar a bit above and then bend, and this portion is 10 centimeters. So we need to add this one also. So after adding all this four, the length will get us 4.1 meter. So we have length, number, and this. So we can have the quantity as 38.87 kg. So what's left? It's the tie bar. Okay, lateral ties. It's given ties 15 mm dia, 10 mm dia, 15 centimeter pitch. Okay, so what will be the length? Is the column, the vertical bar. I'm going to place in helical form. Okay, as this is a circular column, and length of one ring will be from this to this. That means the circumference of the column, but we have to minus the cover from both ends. Okay, see, the length will be pi d, and d will be, already the diameter is given as 30 centimeter, but we will deduct the clear cover, 0.08. So the length will be 0.7, and number, what is the number? We will give the lateral tie from ground level up to the beam, and the total length will be 0.3 meter plus 60 centimeter. So number equal to 0.30 plus 0.60 divided by 15 centimeter, so 0.15. And the same concept, we have to plus 1, and the number we get is 27. Okay, so multiplying 0.62, number 27, and length 0.7, the quantity will get it as 11.72. Okay, so adding all these four, we get the total quantity as 115.96 kg, converted to quintal, that is 1.16 quintal. Okay, so the next will be, we need to prepare the abstract of cost. I have already told you before, abstract of cost is nothing but a table where you have to mention the calculated amount of quantity and the rate from SOR. Okay, I am following the endeavor, so I have put the rate from there. Okay, but in your exam you will be provided with the SOR, so you can put the rate from there also. Okay, you need to multiply the quantity and the rate to get the amount. Okay, so we have calculated we have calculated the quantity under 5 item of work, and I have written it here. So wait, yeah, 5 item of work, and the quantity you can see here, and the rate is here. Okay, by multiplying the rate and quantity you can have the amount, and the total is 2013.65. but this is not the estimated cost. Okay, after getting the total amount, we need to add 5% on the total amount for contingencies and work charge establishment. Okay, so the 5% of this amount is 100.68. so grand total is 2,114 rupees and 33 paise. Okay, this is the estimated cost. I have mentioned something here. If you're asked to estimate the centering and centering portion separately, you can do like this, but I'm not going to discuss this portion as we have one separate unit as quantity calculation for shuttering of different item of RCC work. Okay, I'm going to discuss that separately in another class. So heading towards the schedule of bar, you have already calculated the length, weight and all. So in this table you need to draw the shape of bending and have to mention the dimension also. Okay, so whenever you prepare the schedule of bar, just I'm referring this portion, quantity calculation of steel bar. Here we have done in 4 different head because we are using 4 different type of bar and with bending. So first one in the base footing and the shape will be like this. Okay, why 198? Because it was of 200, but clear cover minus 4 in both ways, so 192. Okay, length you have already calculated as 2.14. Number also, to find the total length you need to multiply number and length, and weight you know. Okay, so next 16 mm that dual bar was like this. Okay, you don't have to show the calculation here. Simply you can write the length and just draw the shape. Okay, the bent is 15 and the vertical portion is 112, and the third one is vertical bar and the bent is in the upper portion. See, and the bent was 10 mm and the vertical portion is 400. Okay, and finally the lateral ties. These are the vertical bar and this is your lateral tie. Okay, the length will be from this to this. This is all total one circular type, and we have already calculated the length, so put it here and this. So this is all about your detailed estimate of RCC column.